My name is Natalia Grier, and I will be presenting my linear programming problem for my Unit 12 math project. The theoretical problem that I came up with to solve is based on Operation Christmas Child and the fact that they send shoeboxes full of gifts to underprivileged children in third world countries to help them learn about the love of God. So, in this problem, the planes that will be carrying the shoeboxes will have a limited space of 15,000 cubic feet, and their weight limit will be 35,500 pounds. As for the shoeboxes, the space that they take up is equal to 15 cubic feet, and they weigh 10 pounds. Now, one child will receive the shoebox, but it is theorized that it will also allow Operation Christmas Child to reach 10 more people as they tell others about the gospel, their friends and their family. So, the reach of each shoebox is 11 people. And to add another variable to our system of equations that we're going to be making, I decided to use a soccer ball and a pump because they'll also bring those along to live with the children in the villages as another form of, entertainment and a community. So for the soccer ball and pump combo, the space that they take up is equal to 3 cubic feet, and they weigh 8 pounds. And assuming that there are 10 children playing, 5 for each team in a soccer game, then the reach of each soccer ball and each pump will be equal to 10 people. So now that we have all of the information that we need to make this linear programming problem, we'll start with the objective function, which is, if we're looking at the number of people that we can reach, will be equal to the number of shoe boxes times how many people it can reach, which is 11x, plus the number of soccer balls and pumps times the amount of people it can reach, which will equal 10y. So now we have our objective function, we need to make the constraints, which will be made using a system of equations. And the way that we will make that system of equations is using this information here. So if we start with the space that we have available in the airplane, we're going to look at, we have 15 cubic feet per box, which will be 15x, plus 3 cubic feet, which will be 3y. It has to be less than or equal to the total amount of space that we have available in the airplane, which in this case is 15,000 cubic feet. Now, as for the weight that this plane can carry, the boxes each weigh 10 pounds. That will be 10x plus the weight of the soccer ball and pumps, which is 8 pounds, so it'll be 8y, is less than or equal to the weight that it can carry, which is 35,500 pounds. Now that we have all of our information, we're going to use our constraints to make a graph so we can see the number of people, the maximum number of people that can be reached. Now, looking at our first constraint, we will write it down. 15x plus 3y is equal to 15,000. Now, if we do the math, then the x value comes out to 1,000, and the y value comes out to 5,000. So when we put that data into our graph, we can see x is 1,000 and y is 5,000, and then we simply connect those 2 points. As for our second equation, we get 10x plus 8y equals 35,500. 100. And when we do the math, the x value comes out to 3,550, and the y value equals 4,437.5. Now, when we graph those, they come out to approximately here and right about there. And then we connect those 2 points. We see our median comes out to about right here. Now that we have everything graphed out, we're going to make a chart so that we can see the maximum number of people that can be reached sending one airplane. Now we've finished solving our linear programming problem, and the final answer that we came up with is that the maximum number of people that can be reached by sending one airplane is 44,400 people. The maximum number of shoeboxes that will be sent in one airplane are 400. And the maximum number of soccer balls and pumps equal to 4,000. And that is the final answer to my linear programming problem.